Let's discuss the problems on measures of dispersion, in which we are going to discuss all the methods which are needed to calculate measures of dispersion, and all the dispersions will be explained one by one. So let's start. As we already understood that what is dispersion, so we can understand it as a scatteredness of the values. And we have also learned that how dispersion can be explained, how dispersion can be understood by different examples. In the previous lecture, we have already explained all this. So let's learn, as it is a measure which actually gives us an idea about the scatteredness of the values. That is, what is the data is actually trying to represent us. How we can analyze that what is the meaning of the data, what is the variation in the data, and what this variation is actually explaining. So all this can be understood by this dispersion. So the different measures which we used for understanding this concept are considered under measures of variation, and these measures of variations provide you an idea of how the data or how the data sets are actually spreaded in the given whole observations. So the scatteredness or the variation of the data can only be understood if you have the knowledge of all the different measures of dispersions. So let's understand all these measures one by one. We knew the names of these dispersions as range, interquartile range, standard deviation, and different others, which we are going to discuss. So let's start with the next one. These are the different measures of dispersion, which we are going to understand with the help of different examples. So first is your range, second is mean deviation, third is quartile deviation, the fourth is standard deviation, fifth is variance, and the last one is coefficient of variations. So let's understand all these one by one. As we knew what range is, I have already explained theoretically what range is, and also by a few small examples that what is actually we understood by this range. This shows you the limit. This shows you the variation in a short form. That means if you want a quick idea related to the data scatteredness, then the range is the concept which we can use to find out that variation in simple terms. So let's understood this range. What actually range explains us. These are the different methods which are used for among one of the measures of dispersion that we knew, standard deviation. And these standard deviation, the calculation of this standard deviation depends on the data type, that what type of data is it a ungrouped data or it is a group data. The same thing happens with other methods, that first of all we need to understand how to understood or differentiate the data as grouped or ungrouped. So the simple thing which we can here understood as for the difference is, if you are given with the limits, if you are given with the boundaries, for example, you are given that class intervals, then that shows your grouped data. That is the limit, the data varies between the limits. So 10 to 20, 20 to 30, just like that, the variation is given. So this is called a grouped data, where frequency is also given. And in ungrouped data, there you are not having any limited boundaries. That means you're not having any limits, or I can say the data will not be in class intervals. So individual series, you can take it as an individual series. That can be an example of ungrouped data. Discrete series, which is not having also the class and limits, but having the frequency only. And all the last are showing you the methods which we use to calculate standard deviation. Let's understand these methods by examples. As I said, the first measures of dispersion is our range. And what range actually explains is, as I said, that range is a medium to understand or to get a quick idea related to the data variation. So by having the lowest and, or we can say the largest and the smallest value of the data, we can find out the range, because the range can be calculated by the difference of these two values. When we calculate the difference of largest and the smallest value of the data, that actually gives you range from which value the data starts variation. The variation starts in the data. So range is L minus S. Then we find the coefficient of range. The coefficient of range is just the ratio of the difference of the largest and the smallest value and the summation of the largest and the smallest value. So the formula which comes as a coefficient of range is L minus S divided by L plus S. Let's apply this formula and other formulas also of different measures of dispersion. So in the next slide, we will understand that. This is squares of deviation from the mean. When we use the deviation method, this will be applicable there. So we will discuss it when we go through the mean deviation method. So there we will find out, there we will use this squares of deviation from the mean. Variance. What actually variance explains to us? The mean of the squares of the deviation from the mean is called variance. For calculating the variance, the first thing which we need is what I have already told you, that is mean of the squares of deviations. What are these deviations? These deviations are actually the difference of the data given from the mean, or that mean may be the actual mean or the assumed mean. So the first thing which we do is to find the deviation, we just find out the difference of all the data from the mean. That may be or actual or assumed mean. And after finding the difference, we sum all the squares of the differences together and we find out the variance. And the formula we use, the symbol we use is given here as sigma square, where sigma represents the standard deviation and sigma square represents variance. So here you can understand that variance, that is sigma square, is equals to summation x minus x bar. Here we have used I equals to 1 to n. That means the number of data is not given. So we are using that there are n number of data. So this formula is xi minus x bar whole and divide square and divided by n. So let's understand the next one. The next measures of dispersion we use after the variance. After the variance comes the most important and we can say that the highly accurate, the value, when we start calculating the values of measures of dispersion, as I said, range gives you a quick idea regarding the data. In the same manner, standard deviation give you the depth, in-depth meaning of the variation. So this is the little bit difference between these different measures of dispersion. So standard deviation is very important and very, what we should say, it is actually the best method among all these to have an in-depth idea regarding the data variation. So how we use it, what is the formula of this? The positive square root of variance. Standard deviation is related to variance. And what is that relation is? We just do the square root of the variance. We do the same calculations and after calculating the variance, we just do the square root of the variance and we get the standard deviation. And this is the method which gives a clear idea about how far the values are spreading or deviating from the mean. The spreadness actually been considered from the mean. The first thing is to calculate the mean of the data, and after that we start finding out the spreadness. So standard deviation provides us a clear idea regarding how far the values are spreading. So this is the formula of standard deviation, and it can be understood in a much better way when we go through the calculations. Let's move on to next. That is the different methods we used for finding the standard deviation. As in the previous chart, we have shown you different methods and the grouped and ungrouped data variation also. So this is related to that particular concept, that is standard deviation for ungrouped data. The calculation or the formulas we used according to the following categories. The first formula we use is direct method. The second formula we use is mean method. The third formula we use is assumed mean method. And all these three are used for finding the standard deviation of ungrouped data. In the same manner, when we have to find out the standard deviation of grouped data or continuous frequency distribution, we say, then in that case, the methods are mean method, assumed mean method, and the last is step deviation method. So the two methods are almost similar, and the last one which is added is a step deviation method. Let's understand these. This is the first direct method. And in this direct method, you can see that standard deviation, that is sigma, the calculation of sigma is same just like we have done the calculation for variance. And what we have done for variance, here you can see in the formula, we are using few symbols, that is x and x bar. What is this x? This xi represents the data given, that is the value set, the data set given. And this x bar is the mean of that data set. We find out the mean of that data set and we start subtracting it from each value. And after subtraction, we just square all these values and find the sum of all those. And after finding the sum, we divide that by number of observations, that is n, or the sum of the frequencies. And we take out, after division, we take out the square root of the value which we have calculated. And that shows you standard deviation. So the formula you can see in the red or the pink, in the pink color, you can see here, sigma is equals to summation under root summation xi square divided by n minus bracket summation xi upon n whole square. So these are the two forms in which you use standard deviation. Both are similar. The next method is assume mean method. But before that, let's understand the direct method with the help of an example. Here you can see an example here that the number of televisions sold in each day of a week are 13, 8, 4, 9, 7, 12, and 10. And we are asked to find out the standard deviation of the same. So the standard deviation, the calculation of the standard deviation here is hello. Okay, to find out the standard deviation, we just do the two things. That is, the first is we write in the table, we just write the first thing is the data given, that is 13, 8, 4, 9, 7, 12, 10 in under X category. And the second column is of X square. That means we just square these values. And after squaring all these values, we find out the sum of all these values. So the standard deviation or sigma is calculated accordingly. Here we are using sigma is equals to square root of summation xi square upon n minus summation xi upon n ka whole square. Summation xi square, we have already calculated in the table the summation xi square, that is 623. And the number of observations are 7. So we have used here 623 divided by 7 minus summation xi over n ka whole square. So here we will square these values. That is summation xi, that is 63, and it is divided by 7. And we do the whole square of these values. So we will find a value that is under root 89 minus 81. And the square root of 8 is sigma, approximately 2.83. This is the way we can find out the standard deviation for ungrouped data. It is an ungrouped data as frequency is not given. So let's move to the next, how to use the other methods. The second is mean method. As the name said, mean method, here we just find out the difference by mean. Here the deviation is xi minus x bar are the deviations. Then sigma is the sum of deviations. Here we will calculate the sum of the deviations. That is xi minus x bar. So this formula is under root sigma di square divided by n. And this I, the value of this I is according to the question, according to the data given. Is there an n observations, or how many number of observations are given? So it will be understood with the help of an example. So let's understand it with the help of an example. Mean method is the amount of rainfall in a particular season for 6 days are given as 17.8 centimeter, 19.2 centimeter, 16.3 centimeter, 12.5 centimeter, 12.8 centimeter, and 11.4 centimeter. Find its standard deviation. The question is find its standard deviation. So first thing which we do is we have arranged all these numbers in an ascending order. After arranging these numbers in ascending order, we just start finding out the calculation of standard deviation. So here is the table in which you can see that the number of observations, that is n, is equals to 6, and the mean of all these observations is 15. That is, firstly, we have calculated the sum of all these values, and after that we have divided by the number of observations, and here we find out the mean as 15. So let's start finding out the deviations now. Here the first column shows you the given values of the data set, that is xi, these are the given values. And in the second column you can see is deviations. So what deviation is? Deviations is to calculate the difference of the data set values from mean. So xi minus x bar. So we have started calculating the difference from 15. And on calculating this difference, we found the values as minus 3.6, minus 2.5, minus 2.2, and 1.3, 2.8, 4.2. In the third column, we have found out the square of the deviations. So here you can see the values as the square of 3.6 as 12.96, the square of 2.5 as 6.25, after that 4.84, 1.69, 7.84, 17.64, and the sum after that of all these deviations is 51.22. This is the sum of all these deviations. So now we have to calculate sigma, that is standard deviation. So let's understand how we will calculate the standard deviation for this. We use this deviation for finding out sigma. So in the next slide, we will understand what will be the value of this deviation. We find out the deviation, the sum of the deviations is 51.22. And we knew that the number of observations is 6. So we just take out the square root of the division of this value. That is under root 8.53. Under root 8.53. Hence, sigma is approximately 2.9. So the value of the sigma is approximately 2.9. That is the standard deviation. Sigma shows standard deviation. So the standard deviation of this is 2.9 approximately. This value is in decimals, so we are using the word approximately. The third is assumed mean method. This assumed mean method is not so much different from the mean method, but the basic difference is that here we are not using the actual mean to differentiate the values or to deviate the values. We are using the assumed mean. And after calculating the difference from the assumed mean, we do the same process which we have used for actual mean method. So let's understand this also with the help of an example. Let's understand it. The example of assumed mean, the example of assumed mean will show you that how assumed mean, the first thing is what is assumed mean and how it will be used for finding out the standard deviation. So let's understand the same thing. Let's move on to the next slide to understand it. Here you can see we are having a question, that is the marks scored by 10 students in a class test are 25, 29, 30, 33, 35, 37, 38, 40, 44, 48. And they are saying find the standard deviation. So here we will not use the actual mean for finding the difference. Here we will use the assumed mean. The mean of marks is 35.9, which is not an integer. Okay, the question comes is why we use assumed mean? Because sometimes when we find the average, when we find the mean of the data, the value not always comes in integer form. The value may be in the decimals. And for finding the difference from the decimal value is a difficult thing. That is a difficult part when we start finding out the differences from a decimal value. So we just convert that value, the mean of that particular data, we just convert it into integer form. So when we find the actual mean of this data, that will be 35.9, but that's not an integer. So we will take the assumed mean as 35. And the number of observations given is 10. So let's understand how we will calculate it. Here you can see that we are having a table where the first column is of the data given, the second column is of deviations, and the third column is of deviation square. So the square of the deviations will be summation d square is equals to 453. The sum of the deviations is 9. And let's use these two things for finding out our standard deviation. Because we knew the formula of finding the standard deviation with the help of assumed mean, which we have already learned. That is sigma is equals to square root of summation di square divided by n minus summation di over n, and the whole square of that. So let's find out the value of summation di, that is 9, and the value of summation di square is equals to 453. So the value of the summation d square is equals to 453, and we will use that value for finding out the deviations. That is the divisions of that from the number of observations. So we have put that value, that is 453 divided by 10 minus 9 by 10 whole square. And on subtracting these two values, that is 45.3 minus 0.81, we get 44.49. And the approximate value of standard deviation we get is 6.67. That is the value of the standard deviation of the given data. So in the second column, you can see in this question that we have finded out the difference, and in this difference we are also having some negative signs, right? So these negative signs will be removed when we square this deviation. So d square is the square of all the deviated values. Let's understand the next method. We have discussed the mean method, the assumed mean method, and now understand the most important, that is the step deviation method. In this step deviation method, we just use the assumed mean for the deviations, but along with that, we also use the class intervals which are given in the data. So the class interval is also used for finding out the deviation of the given data. The formula you can see here is sigma is equals to the C is class interval multiplied by under root summation di square over n minus summation di upon n whole square. That part is similar with the previous one. So you can understand it in a much better way that what a small difference in this formula is. Let's understood it from the first part. That is, what is di here? In the previous methods, we find out the di just like xi minus assume mean or xi minus mean. But here the di means the difference will be from the assume mean, and that difference will be divided by the class interval. That is xi minus a upon c. This is the way we find out the deviations. So let's understand it with the help of an example. All this can be explained by using an example. Let's move on to the example. And there we use all these things, how we calculate the deviations, how we will find out the mean, and how we will find out the standard deviation. Let's have an example. In this example, you will see we are having some values. That is the amount that the children have spent for purchasing some e-tables in one-day trip of a school are 5, 10, 15, 20, 25, 30, 35, 40. And here we are asked that we have to use a step deviation method and find the standard deviation of the amount they have spent, that how much amount they have spent for purchasing the items during their trip. So here you can see that all the observations given are, we note that all the observations are divisible by 5. Hence, we can use the step deviation method. We can use the step deviation method here, and the assumed mean which we calculate here is, we have supposed that the middle value of this data, we have just taken the middle value like that. So we can use any 20 or 25 or among 20 and 25, as the values are 5, 10, 15. That is 3 and 1, 2, 3, 4, 5, 6, 7, 8. These are 8 values. So the middle is the 4 values are in the left and the 4 values in the right. So here we can choose any of the 2 values, that is either 2, 20 or 25. So we have used assume mean here as 20. And the number of observations, as I said, is 8. So let's start calculating the standard deviation for these values. This is the table of this question, where you can see the first column shows you the data given. The second column shows you the deviations, that is the assumed mean, which we find out as 20. We have subtracted all the data values from 20 and we find the values accordingly. That is minus 15 when we subtract 5 from 20, minus 10 when we subtract 10 from minus 20. And in the same manner, we find out all those values. After that, as in a step deviation method, as I said you, that one thing more is being done here. That is, we used class interval. We use class interval for finding out the deviations. So this is xi minus a over c, where c is 5. And after that, we find out the values as minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. And the summation of these deviations is 4. After that, we find out the di square. and the summation of di square is 44. Let's use these values to find out our standard deviation. Our method of finding the standard deviation by using stub deviation method is sigma is equals to under root, that is the square root of summation di square over n minus summation di over n whole square. And after that, after finding out the square root, we just multiply all these values with 5. That is C. C here is class interval. So we start putting the values, that is 44 by 8 minus 4 by 8 whole square. We get the value as 5.5 minus 0.25, and the square root of that is 2.29, and that will be multiplied by 5. And we get the standard deviation of this question as 11.45. So the standard deviation we found as 11.45 of the given data set. This was the method which we called stub deviation method. Let's understand the same thing for the continuous frequency distributions. Here the mean method is for finding the standard deviation is we start including frequency. We start including frequency in the formula which we have used before for ungrouped data. So here you will see the difference is in the formulas, you will also find out the frequencies. Let's understand it with the help of an example. What is this mean method for continuous frequency distribution? Here the question is given, that is 48 students were asked to write the total number of hours per week they spent on watching television. With this information, find the standard deviation of hours spent for watching television. And we are having the table as we are given X and F. Here X represents your data and F represents your frequency of that data. So 6, 7, 8, 9, 10, 11, 12 is X, and 3, 6, 9, 13, 8, 5, 4 is your frequency. So let's make a table for this and start finding out the standard deviation. This is the table for this question. Here we are having our first column as the data given, the second column as the frequency given, and in the third column we start finding out the multiplication of the data set with the frequencies. So here you will have the column xi into fi. That is, we start multiplying these values. 6 into 3, 18, 7 into 6, 42, 8, 9, 72, 9, 13, 117, and so on. All these values will be multiplied accordingly. Then we find out the deviations, D, in the same manner as we have used in the ungrouped data. That is, we start subtracting the X values from mean of the given values. So on subtracting the data from the mean, we get the summation as summation D equals to 0. And after this, that we will square this data. We start finding out the square of this data, which we use in our formula further. So when we square the data, that is D square, we get different values. And in the last table, we get the summation FD square also, after multiplying the frequencies with the square of the deviations. So here, the first thing which we have found out is mean. And as we have understood in the first unit that how to calculate mean for grouped data, here we have used the formula that is summation xi fi over n. And here the summation xi fi, the value of summation xi fi is 432 divided by 48, that is 9. Standard deviation for the same data set is under root summation fi di square divided by n. And the summation fi di square is 124 as we have got in the table, which we have drawn. And in that table, we find it out that we are having the summation as 124 and the n is 48. So start dividing it. And on division, we get square root of 2.58. The value of the standard deviation we got is 1.6. So this is the way we find out the standard deviation for this method. The shortcut method or the stub deviation method. We've also heard this name before. So as I said, the one thing more which is being added now is frequency and the class interval. So here the sigma is, the formula of the standard deviation is C multiplied by under root summation FIDI square. The F was not there in the previous step deviation method for ungrouped data. But here we will use FIDI square divided by n minus summation FIDI over n whole square, and the square root of this will be multiplied by the class interval, and that will give us the value of the standard deviation. So we will also understand it with the help of an example. Let's have an example related to this. That marks of the students in a particular subject of a class are given below. So here the marks are given. We are having the class interval of marks, that is 0 to 10, and this limit is going up to 60 to 70. And the frequency is also given, that is the number of students. Number of students shows you frequency of occurrence of these marks. So the frequency given is 8, 12, 17, 14, 9, 7, and 4 for the respective class intervals. So here you can see the first thing which we have to find out is the assumed mean. And the assumed mean here is 35. That is the frequency, or you can see the class interval will be taken as, the assumed mean will be always be taken as the middle value of the data given data set. So 30 and 40, the mid value of these two is 35. So we have used assumed mean as 35. The first part is mid value. We start finding out the mid value of the class intervals. From the class intervals, we will start calculating the mid values. For example, the first class interval will be 0 to 10. So that will be divided by 0 plus 10 divided by 2. That is 5. In the same manner, the next class intervals will be calculated. That is 10 plus 20 divided by 2. That is the next mid value will be 15, and so on. Next is frequency given, and the third column shows you the difference, the deviations, that is xi minus assumed mean. That is the difference of the data set values from the assumed mean. After that, we find out the division from the class interval. That is d divided by c, di divided by c. That is, all the deviations will be divided by class intervals. And after calculating this, the next column is multiplication of the frequency with the deviations and the squares of the deviation. So the last two columns are showing you summation fi di equals to minus 30 and summation fi di square is equals to 210. So let's start calculating the standard deviation for this. Here the sigma will be calculated by the formula we have already learned. Here we will start putting the values which we have found out in the table. That is summation fi di square 210 and summation fi di 30 and 71. So on squaring the values, we get 900 divided by 5041, that is 5041. And the previous one was 210 divided by 71. And this is the class interval which is in front, that is 10 multiplied by under root values. So on calculating all this, on multiplying the class interval with the square root value, we will get the value as 16.67 of standard deviation. So the standard deviation of this question by using the shortcut or step deviation method is 16.67 for for grouped data, or continuous frequency distribution or grouped data.